Dear students, this is National Anveshika Experimental Skill Test Screening Video question. So please watch completely. After this, we will know about the solution. So here is a question: why the separation between magnets 2 and 3 is more than the separation between magnets 1 and 2? And in addition to this question, we have two more questions. The first one is, which of the pairs of magnets repel each other and which attract each other? And second question is, what is the resultant force on magnet 2 and magnet 3? And the third question already repeated this one, why the separation between magnet 2 and 3 is more than the separation between magnet 1 and 2. For the solution, let us draw the free body diagram as shown in the figure. Here there are three magnets, 1, 2 and 3, and three magnets have the same mass and the acceleration due to gravity is g. So the weight of the three magnets are equal, that is mg, and this mg is always acts in downward direction. This one mg and this is also mg, this is also mg. Now the normal reaction force from base 1 on magnet 1 is capital N, and here the magnet 1 and 2 repel, also 2 and 3 repel, but 1 and 3 attract. How can we say this? You clearly observe that these two magnets are in hanging position. That means there is a repulsion force between these two and also a repulsion force between these two. So let us assume that it is say north pole and it is say south pole. So since there is a repulsion between these two, so it is south, automatically it is also south, and this is north, and these two are also in repulsion, so this is also north. So this is one is north pole and this one is south pole. So there is an attraction force between 1 and 3. So here let us assume F12 is magnetic force on magnet 1 due to magnet 2, and F21 is the magnetic force on magnet 2 due to magnet 1. So this is F12 and this is F21, and these two are equal and opposite in direction. So F12 is equal to F21. Similarly, for the magnet 2 and for magnet 3 also observe. So here F13 means the magnetic force on magnet 1 due to magnet 3, say F13, and it is acting upward direction, and F31 is the magnetic force on magnet 3 due to magnet 1 and it is acting in downward direction. So F13 and F31 also equal, and similarly F23 is the magnetic force on magnet 2 due to magnet 3, and F32 is the magnetic force on magnet 3 due to magnet 2. So these two are also equal and opposite. So F13 equal to F31 and F23 is also equal to F32. And also we observe that all the magnets are in stationary position. Hence, according to Newton's second law, the resultant force on each magnet is 0. And here, if we observe for magnet 1, there are 4 forces. Out of 4, 2 forces are acting in upward direction and the remaining 2 forces are acting in downward direction. Take upward forces as positive and the downward forces as negative. then the resultant force on magnet 1 F13 plus N minus F12 minus mg is equal to 0. And for magnet 2, upward force is F21 and downward forces are F23 and mg. So we can write as F21 minus F23 minus mg is equal to 0. And for magnet 3, the upward force is F32 and the downward forces are F31 and mg. So the equation for magnet 3 is F32 minus F31 minus mg is equal to 0. Now substitute F13 equal to F31 and F32 equal to F23 and F21 equal to F12, these values in the above three equations. Then here we can write this equation as it is, F13 plus N minus F12 minus mg is equal to 0. But here instead of F21 we can write as F12. So the second equation becomes F12 minus F23 minus mg is equal to 0. And the last equation, replace F32 as F23 and F31 as F13. Then we get the third equation as F23 minus F13 minus mg is equal to 0. Now adding or solving these three equations, F13 minus F13 get cancelled, F12 minus F12 get cancelled, and minus F23 plus F23 also get cancelled. So here N minus mg minus mg minus mg, so minus 3 mg is equal to 0. N minus 3 mg is equal to 0 means N equal to 3 mg. And from this equation F12 is equal to F23 plus mg. And here if stand is kept on a pan balance, then pan balance will measure N equal to 3 mg. So also repulsive force between 1 and 2 is greater than the repulsive force between 2 and 3 because F12 is equal to F23 plus mg. And this also possible when distance between 1 and 2 is less than the distance between 2 and 3. So that means magnetic force increases as distance between magnets decreases. This is the solution. Thank you for watching.